Dear student, it is the second class for linear differential equation, that is integral calculus. Integral calculus, it is a very most important chapter. So more 2 classes, so it is the second class, and it will be extended by giving 2 more classes. Thereafter the revision on the stage for at a time for one class 2-3 chapter will be revised. So I am requesting those are doing online classes, those are enjoying the video classes, those are taking my video classes from BTS by test series, they should adhere it and they should make continuity to go through this, so that entire syllabus will be covered, and it is in the graduation level. Calculus is also important or for other exam. So also I am requesting, I am giving more and more classes on YouTube, more classes on BTS and other institution, and for which I am requesting for the Kundu sir channel, those are interested or want to learn, they can subscribe. So I will be inspired by them to take more classes for 12 mathematics in the structural way. Now I am going to start problem number 1 for the class. Problem number 1. Problem number 1 is, it is a very important problem that is solved. That is differential equation. Solve 1 plus x square into dy upon dx equal to dy by dx plus y. Dy by dx plus y equal to e tan inverse x. It is the problem, that is equation which is to be solved. The differential equation, it is what is given, we can compare it, that means in the form. What is the form of standard equation? Form is, what is the form for this? Form is dy by dx plus dy by dx plus p into y, that means p into y into q. Now comparing this one and the given one, I am writing here, we are making comparison. So p equal to, that means we can convert from this, that is dy by dx into 1 by dy by dx into 1 by, that is we can write 1 by plus dy by dx, we are dividing this y upon 1 into 1 plus x square equal to, that is e to the power tan inverse x, e to the power tan inverse x upon e to the power tan inverse x upon 1 plus x square. Here, where you can write here, what is p? That is, we are comparing this p, that is 1 by 1 plus x square, and q equal to, we can write q e to the power tan inverse x upon 1 plus x square, that is p and q, and we are comparing it with the standard equation p dy dx p into this. Now that means the given equation, that is integrating factor. Now integrating factor if. What is the integrating factor? Equal to e the power p dx e to the power integration p dx, and that is equal to e. What is p? What is p here? P here is 1 by 1 plus x square into dx. That is here p and q here. It is the standard form of the equation, and also I am writing. I am giving more clarity, so you do by your own. Just go through my classes. Sometime if you forget, go through my video class or go through the BTS classes, and you can prepare yourself. So it is, we know integration x square plus s square into dx equal to 1 by a tan inverse x by a. So it is equal to, it is 1. So it is equal to, the result is e to the power tan inverse x. We have got the integrating factor. So this required solution for the given linear differential equation. So what? So therefore the required solution, the required solution of the given differential equation equal to y into if, integrating factor, then integration. What is the integration? Integration equal to, that is integration is to be done for these, that is equal to what? That is q into if, q into if, q into if, q into, or give a into mark here, and q into if into dx plus c. That is equal to, we can write into, the solution is y into, then we can write here the q, you can write in this way also, q into if integrating factor into dx. So we can write now, or y. What is integrating factor here? E to the power tan inverse x. We have done here e to the power tan inverse x equal to integration. What is q here? Q here is this, e to the power tan inverse x, e to the power tan inverse x upon 1 plus x square, and into if integrating factor is e in e to the power tan inverse x, e to the power tan inverse x, and this is into dx plus c, this one. Then we have to start from here. So we are that is equal to, what is the result now? That is equal to y into, that is equal to, from here, y into e to the power tan inverse x, e to the power tan inverse x equal to what? That is equal to, we can write this, that is integration of e to the power 2 tan inverse x upon we are doing 1 by 1 plus x square, that is on this, into dx plus c. We have done dx plus c. Now we are writing now what is this? Now this is equal to, we are putting, what we are putting here? 1 plus 1, that is tan inverse x equal to t. What is the result? It is, we are marking as 1, 2 or a. So differentiating a or 1 by 1 plus x square into dx equal to, it is dt. So this portion we can write e 2 into t and dx by 1 plus x square dx equal to dt plus c. So e to the power 2t equal to e to the power 2t upon 2, e to the power 2 upon 2 plus c, that is equal to, that is c. Now or y into e to the power tan inverse x equal to half. What is e to the power 2 tan inverse x? E to the power what? It is 2 tan inverse x, e to the power 2 tan inverse x plus c, that is this one equal to this one equal to this one equal to this one. So from here we are writing here, what we are writing here? We are writing this equal to, we are dividing this one, equal to y equal to, where we are dividing half e to the power, then it will tan inverse x, because we are dividing the left hand and right hand side both. So whatever we are getting, this equal to y e to the power tan inverse x, that plus c by, that is equal to, we are making division. So what we can write? We can write plus c upon tan inverse x, that is equal to, the final result I am writing here, y equal to half e to the power tan inverse x plus c into tan inverse, what is minus of tan inverse, that is, when we are from denominator to numerator, e to the power tan inverse x, that is equal to c, the integration constant, and e to the power minus tan inverse x is the result. Y equal to half e to the power tan inverse x plus c into e to the power minus tan inverse x is the solution